everyone, this is Tirtharaj Mukherjee, and in today's video you will be introduced to logistic regression. But before beginning our journey, let me ask you a few questions first. Did you exercise today? Okay, so you said yes. If I say 1 plus 1 equals to 11, can you prove me wrong? Okay, I agreed. And if I ask you the color of this mango, you would say yellow. So in cases where we have to say whether the answer is yes or no, right or wrong, true or false, or in this case what's the color of this fruit or mango, whether it's red or yellow or green or whatever color, these are all categories, right? Right, wrong, true, false, and these colors, these are all categories. So the problem under discussion becomes a classification problem. It becomes a classification problem. Let's see an example. So in this example, Spider-Man, Batman, Iron Man and Superman, all of them go to a wealth management firm with all their details, like how much money they can spend per month, and whether they have a smartphone or not, and their risk appetite. I mean, how much risk they are willing to take to invest in a mutual fund, because we'll know that investment in mutual funds are subject to market risks. So getting these details from these three people, the wealth management firm says that yes, Spider-Man, you, Batman and Iron Man, all three of you can invest in a mutual fund. But what about Superman? There is a big question mark in his case. Can you answer whether he can invest or not based on the details of these three people? This is where logistic regression comes into the picture. Let us work on it together. I will label Spider-Man's record as 1, Batman's record as 2, Iron Man's as 3 and Superman's as 4, and proceed. We have this innocent looking box to which we will feed the record 1 and it will learn in the process. We will feed record 2 and it will learn in the process more. Similarly, we will feed it the record 3 and it will learn more in the process. And it says, now I have learned. And based on its knowledge, we will ask it to predict whether Superman, that is record 4, can invest or should invest or not. It says no, but Superman was very enthusiastic and willing to invest. So in this case, I recommend Superman that, hey, you should get a smartphone with an internet connection and you can go ahead and start investing. So to this, he becomes happy, buys a smartphone and gladly starts investing in the process. This box is nothing but a machine which learned from records, just like we human beings learn from our experiences and then are able to predict whatever is going to happen in the future. So let us see how logistic regression works in the background. We have this curve right here, this black curve, which looks like a children's park slide, and the x-axis is the independent variable and the p of x on the y-axis means the probability of occurrence of x. What this black curve or this sigmoid curve does is it computes the probability of occurrence of these red circles zeros or these blue circles ones. There is a threshold which is normally 0.5 in the middle, above which the probabilities correspond to occurrence of ones, and below which, below 0.5, it refers to occurrence of zeros. The equation of this sigmoid curve is very simple. It is p of x is equal to 1 divided by 1 plus exponent of minus x or e to the power of minus x. P of x, as we just discussed, is the probability of occurrence of x, which is the independent variable. But in our case of the superheroes, we had 3 independent variables: spending per month, whether they have a smartphone or not, and their risk appetite. So the equation converts to something like this: C1S plus C2P plus C3R plus D in place of X. You see? Yeah. So S stands for spend per month, P for smartphone, whether they have smartphone or not, R stands for their risk appetite, C1, C2, C3 are three coefficients, and D is just a constant. This expression in substitution of X, this long expression, it's called a logit, and substituting this logit in this whole expression gives us the final probability of occurrence of the dependent of the independent variable, and we get the output as 0 or 1. Let's see some applications of logistic regression. We have fraud detection, whether a transaction which is occurring, it's a fraud or not. In the case of stock market, we have seen apps like right? In the apps, they say that whether a stock should be bought or sold, they are said by buy or sell, right? So in that case also logistic regression works. In the case of email filter, when a new email comes into the inbox, whether it's stored in the inbox or it is sent to the spam folder. So if the email is being rightly classified as spam, it will be stored in the spam filter, in the spam folder. And in this case also, what is the breed of this cute dog? It can also be found using logistic regression. So this brings us to the end of this video. I hope it was entertaining and valuable. Thank you so much for watching this video till the end. Subscribe to our channel for more such content. Hit the bell icon to be always notified of our new videos, and stay tuned for our future videos.